in this problem, I'm supposed to find the derivative of this function right here. So they're saying find dy over dx. It's just a different way of writing find the derivative. So in this case, I have a quotient, and I'm going to have to use the quotient property. Let's just write what that quotient property is. So from the book, it says the derivative with respect to x of the quotient u divided by v is equal to v, that is the denominator, times the derivative of u, the numerator, minus u times the derivative of v with respect to x, all over the denominator squared. Well, I like to kind of write this a little bit differently. So what I like to write is this. I know that I have u is my numerator and v is my denominator. So I kind of write, I know I'm going to have some form of u times v minus some forms of u times v. And I do know that it's going to be divided by v squared. And what I like to do is I like to say, well, I know I want the derivative of this, and then I'm going to move the derivative one notch over, and I want the derivative of that. So sometimes you would see it written like this. F prime g, if I was using function f and function g instead of u and v, f prime g minus f g prime divided by g squared. It's just one of those things you're just going to have to figure out your best way of memorizing it. But my best way is using this f prime g minus f g prime, or the u prime v minus u v prime over the denominator squared. So I've kind of erased most of that, but written my little shortcut over to the right. So I know then that y prime is going to be equal to, well, x squared prime times g, which is 1 minus x cubed, minus, kind of move that out of the way a little bit, minus f, which is x squared, and I'm going to put a bracket around this so I don't lose any negative signs, x squared times 1 minus x cubed prime, the derivative of that, all over 1 minus x cubed squared. So to work on this a little bit, my y prime is equal to, well, the derivative of x squared is 2x times 1 minus x cubed, that didn't change, minus x squared times, well, now the derivative of this, I have the sum property, so the derivative of 1 is 0, and the derivative of negative x cubed would be negative 3x squared. And that is all divided by 1 minus x cubed squared. All right, let's press onward. Y prime is equal to, now I'm going to distribute 2x minus 2x to the fourth. I just distributed that and that. Minus, well, inside the brackets here, it's going to be negative 3x to the fourth. And again, that's all over 1 minus x cubed squared. So I have some like terms I can deal with here. Y prime is equal to 2x. Well, this two minuses here are going to be a plus. So I have positive 3x to the fourth minus negative 2x to the fourth. So I have plus x to the fourth divided by 1 minus x cubed squared. And that's really as far as I can take it. This is the answer. Now I will tell you, when I was messing with this, I saw this 1 minus x cubed, and I saw the 2x plus x to the fourth, and I thought, oh, maybe I can simplify a little bit, and I tried to pull out an x, but I got x times 2 plus x cubed, and there really wasn't anything I could simplify. So that was really, this is the answer to that problem. Now, if I want to confirm this graphically, I graphed on the Desmos and then I snipped it out. I graphed the function and I graphed the derivative. So if I'm looking at my function, I can see that from, well, it looks like negative infinity going up to just about 1, I have a positive slope. And then my slope here starts going negative. And then my slope here from 0 starts turning positive again. So let's see if that's true on my graph here. I have positive slope, my derivative is positive, positive here, and then just before 1, it starts turning negative, and it's still negative, but getting less negative, and then right at 0, it's turning positive. So it's staying as a positive slope. Oh, it looks like to about 1, and it is. It kind of stays positive, positive, positive. It looks like some kind of an asymptote there. And then I jump over the asymptote, and down here, where I'm coming up from negative infinity, I still have a positive slope. And the slope is staying positive. It's just getting less and less positive, and kind of looks like it's getting closer to being 0. And here on my derivative, my slope is positive, positive, positive. It's getting less positive, and again, getting close to 0, but still staying in the positive realm. So these two seem to match pretty well. I feel confirmed.